Welcome back everyone, my name is Unintended, and in this video we'll talk about a very important concept, especially for interviews, which is thread safety. Now once you have worked on Java, or if you are learning Java now, we have different stuff available here, right? We have language fundamentals, we have for loop, exception handling, arrays, and then you learn about a concept which is threads. Now if you have not seen the thread video, check description, you will find a link for threads. So we know threads are very important, because in your machine you will be having multiple cores, and if you want to execute multiple functions at the same time, we can do that with the help of threads, right? So you can achieve one task with one thread and you can have multiple threads, and that's amazing, right? So yes, threads are very important, but with some issues. To understand that, let's understand the concept of mutation. So whenever you have an object, that object will have certain variables. If you can change the values, that is mutation. So that object is a mutable object. So on the other hand, we have immutability. So you guessed it right, immutability simply means you have the object. In that object you have some variables and you can't change the values of those variables once assigned. That's immutability. So now you will think that mutability is better than immutability because you can change values. And that's what we do in software industry, right? So if you have a software and if that works with data, of course there should be an option of changing the values, right? And that's how you can perform operations. So yes, mutation is important. Multi-threading is important because you can have multiple threads, but when you combine them, that's where the problem starts, right? So if you have multiple threads and if you have a data which is shared by all these threads, that will create issues. Yes, if you are simply fetching values, there's not an issue with that. But the moment you change values, that's where problem starts. To understand that, let's see an example here. So if you can see, we have a very simple class here, counter, in which you have a variable count. And in this you have a method which is increment, which is changing the value of count. So when I say increment, it will update the value, right? And then in the main method, we are creating the object of counter, and then we can simply call, or we can, we can print the value of count here. So I can say c.count. And if you run this code, of course, it will print the value of count for you. And you can see we got the value which is 0. So that's the default value, right? But what if you change it? Now we can change the value, right? We can call increment by updating it. But then I want to do increment multiple times. So maybe I want to do increment, let's say 2000 times. So yes, you can write a for loop here. So we can write a for loop which starts from A1, and then we can say I less than equal to 2000. And then we can say I plus plus, right? We can do this. And every time you run this loop, you can simply say c.increment. Your job is done, right? If you run this code, at the end, the output you will get is 2000. But you might be thinking, hey, let me just optimize this. Let me just use multiple threads here. So just do that. So what I will do is, I will use two threads. One thread will call increment 1000 times. The second thread will call increment 1000 times. So in total, the increment will be done 2000 times, right? That's what we want. So let's create two threads here. So I will say thread t1 equal to new thread. So there are multiple ways of creating thread, right? This is one of the ways. So you can pass the object of runnable, and in this we can create a method which is public void run, because thread normally works with run. And whatever you are doing here, will simply cut this part and paste it here. So you can see we got one thread. Now this will not run for 2000, this will run for 1000, our choice. That's your first thread. We'll copy this and we'll paste it here. That's your second thread. So let's say t2. And this will again call increment 1000 times. So we got two threads, each is calling increment 1000 times. And now let's say start. So we'll say t1.start and t2.start. Okay. And then we have to also make sure that your threads are waiting. So your main thread should wait for both this thread to complete. So let's say join, right? And then it might throw the exception. So let me just simply go for throws, which is not a good coding practice, but we don't care about that as of now. Let's say exception. So basically we got two threads and we are saying start and join. And then it should work, right? Because we have two threads and it will run parallelly. So it will improve the performance, right? So it will work faster than normal code. So the output we were expecting is 2000, but we got 1600. That's weird. See, every time I run this, I will get different output. That means there is something inconsistency here. Yeah, once you got 2000, but there's no guarantee that you will get this value again and again. The moment I run this code more times, you can see we got different output. What is happening here? So this is what we want, right? We want to achieve thread safety. What is thread safety basically? So when you have multiple threads working on the same method, and if that method is changing the value of a data, that's not thread safe, right? So your method is not thread safe. And when your method is not thread safe, you will get inconsistent value. And we don't want that, right? In the software industry, data is very important and you want your data to be consistent. How do we achieve that? So one way is whenever you write a method, make sure that your method is not changing values. You can simply make a class immutable. But then here we want to change the value, right? Immutability will not work here. So what is happening here? Now, whenever you have multiple threads working with the same method, so let's say both the methods are going there and they're trying to perform the operation. Now this operation, which is count plus plus, it looks like an atomic operation, but it's not. Multiple things are happening here. The first thing it is happening is it is fetching the value for count. So it will fetch the value for count. Let's say the current value for count is 100. Then it will add the value by 1, which will make it 101, and then it will assign the value which is 101 to count. So it's not one-step process, it's a three-step process, right? So it's not an atomic operation. And that's where the problem starts, because if two threads are reaching to the same point, both will ask for the value for count. And then count will say, hey, my value is 100. So the thread 1 will assign 101, thread 2 will also assign 101. Right? That's where we are missing our data. So we don't want both the threads to work with count at the same time. So we want to achieve thread safety here. So thread safety simply means that this method will be executed only by one thread. Now there are multiple ways of doing this. One is by using synchronized keyword. So by saying synchronized here, we are saying that this method will be called only by one thread. So let's say if T1 is accessing increment, T2 has to wait. If T2 is accessing increment, then T1 has to wait. Now if you run this code, you can see we got 2000. So every time you run this code, you will get 2000. This is one way. The another way of doing this is, let's say I don't want to use synchronized, then how can I achieve this? So instead of using int, we can also use a wrapper class, but then an atomic wrapper class. So we might have heard about integer, right? So in the same way, we also have an atomic integer. So whenever you want to achieve thread safety, better to go for atomic increment, but provided you want to perform atomic operations. So let me create object of atomic integer. So you can see it's not just integer, we also have atomic boolean, atomic long, whatever you want to use. So let me just, not boolean, I want to use atomic integer. Okay, that's done. Let me import the package once again. So you can see we got atomic integer, and now if you want to perform the operation, we can't say count plus plus, right? That will not work. So if you want to increment, you will say count, increment, and get, right? That's what we want. And that's it. And then here we can't simply print count, can we? Let's try. Let me run this code, and you can see it works. Benefit, right? We are not using synchronized keyword there. So you have two choices. You can also use synchronized as a synchronized method, which will make sure that it is thread safe. You can also use atomic integer, which will make sure that it is thread safe. Now you will hear this concept thread safe with multiple stuff. Example, we have two classes in Java, string builder and string buffer. Example, if you go to string builder, so both does the same thing, right? They provide you option of changing the string value once assigned. So we have string buffer and we have string builder. So one is thread safe, one is not. So if you read the documentation, somewhere it will say it provides synchronization, it doesn't provide synchronization. You can say a thread safe mutable sequence. That means this is thread safe. So all the methods here are synchronized, right? That's important. Not just this, if you are working with hash map, there's one more thing which is concurrent hash map. So if you go to concurrent hash map, again, we have an option of hash map, right? Why to use this? It's because even this says, if you go up, so you can see here it says it's thread safe, right? So that's the advantage. So you can, if you want to achieve thread safety, if you have your own variable like int, you can go for atomic integer. If you have a method, you can use synchronized. If you're working with collection or map, you can use concurrent hash map, right? So that is thread safety for you. So I hope you enjoyed this video. Let me know in the comment section and please subscribe for further videos. Bye.